Hello, folks. Welcome back to Learn Synthesis with VCV Rack. I'm your host, Lawrence W. Moore, and this episode was originally going to be our first episode in filtering, but I received a comment that was really valuable, and I decided timing-wise, it's good to look at this now. The comment was from F. Ranky, and in addition to some kind words, I also received some advice, recommendation that I think will help us all build a little bit better instruments in so far as the design would be sleeker and the processing demands would be cut down as well. And as you build more and more complex instruments, the amount of processing, since we are using digital software here, the amount of processing that's going on is an important thing to consider, because if you can achieve what you're looking for with less processing usage, go ahead and do it, because you're more likely to get stable sound and less glitches as you do so. So in any case, we're going to take a look at this, and I hope this all helps you out. I believe it will, and it's certainly going to affect how I design instruments going forward in this series. So thank you, F. Ranky. Here we go. Okay, so to introduce this concept, let's look at the patch at the end of the last episode. Now this is a 3 oscillator set. MIDI is feeding the 3 different carrier oscillators, and each of these oscillators basically is going through a very similar series of processing before going to the mixer and then going out through the audio module. Mostly we just need to look at one of these. We have a VCO that's generating our sound, sawtooth in this case. I have a process module here that's used to allow velocity to control the level with a bit of glide in between the velocity values, so the changes in them is more smooth and you get less artifacts, those snapping sounds. If you watch the last episode, episode 3, you will see that's included, even though it's not in the title. So anyway, that velocity then is kind of governed already. Well, it governs the amplitude of the sound already before it becomes the initial attack peak here. And then when you play different notes, it's maintained at the sustain level, but switching between the notes, well, that's a buzzy sawtooth, so you wouldn't really hear the difference, but in episode 3 it's a little bit more clear. But basically, when you play one note and another and another and another in sequence and don't release the previous note, the envelope stays in the sustain level, and if your velocity is fluctuating too quickly, which means from one note to the next, that's going to happen, this process makes it smoother note to note. So in other words, we need this process, and we have a VCA being controlled here to execute that. And then after the envelope, we have another VCA. And this is basically allowing the sound to be governed by the envelope as well, second in the chain. And then this mixer here is basically being used to combine our 3 oscillators, 2 sawtooths, and a sine at the bottom. Okay, so I'm going to open up a patch that I prepared for this episode here, where we're going to look at a sleeker way of doing this. And to start, we're just going to deal with one oscillator here. So you see, we have a VCO here. We have the process module here. We're going to use the process module again, and we're going to continue using our envelope generator. Down here, I put a mixer, and the audio module. These are all from the VCV Rack brand. They're all free ones. And in episode 1, I show you how to download from the library and filter for just VCV and free. And that way you should have all these modules in your set. Okay, so we do need to control pitch with volts per octave here. And that goes in right here. We are going to use this gate for two things. One, to control our process module here so that it knows when note on and off messages are coming in. And we need it to control our envelope generator here, because that also needs to know when notes on and off are coming in. The velocity goes into the input here on process. It's basically a CD input, so the velocity information comes in here. And then the glide output here, which gives us our smoothing from one velocity value to another. Okay, this is where the new step comes in. This would normally go to a VCA that controls the signal level from this oscillator before it goes forward to the envelope. What we're going to do here is take this glide output and put it to the control input of channel 1 on the mixer. Notice how channel 1 and 2, 3, and 4 all have individual control inputs. They also have audio inputs, and they have individual audio outputs. The overall output here of the mix from the module is also an output, but we can effectively use the individual channel outputs as well. And this is how we're going to do it. Let's say we want to use, I'm going to do a sine right now, because there's also something I want to show you about the process module. We're going to use a sine as our channel 1 input here. The audio inputs are the lower ones, the control inputs or CV inputs are the top ones. Okay, so the sound is coming in there, and the glide is controlling it. So the output sound-wise here would be the sound signal, the sine wave, governed by the velocity level coming in, because that controls basically the level here, which is its mix level. Now we're going to take this output and put it to the audio input of channel 2 on the mixer. This output here is not audio, it's basically control output from the envelope gate, and that is going to control the audio coming into channel 2. So we're not using any VCAs here, but we're basically replacing them with 2 channels of the mixer. And then the audio output here is going to go into our audio module, which outputs to our interface. And so there we are. You hear, we get sound. Heard a little snap there because I didn't turn up the slew at all. Incidentally, I found I was turning it up to 12 o'clock. And I was still periodically getting some artifacts here and there. I turn it up to a lower amount here, and I think what this is giving us is a shorter time-wise transition from one velocity value to another. It's enough that we don't hear artifacts, but it's not overly long in that if you get to like a third note quickly, you're less likely to produce an artifact. Now and then I do hear one, maybe when I'm too quick, but it is better than when I had it in the 12 o'clock position. Let me lower it a little bit more. I'm still hearing some now and then, but it depends on the music that you're playing. So if you just want to do a glissando, I don't hear them there, and so forth. Now, this tends to be covered over if you're using more complex wave shapes. So we're actually going to do that now because there's another thing to look at here. I was thinking, okay, so we accomplished, instead of having two VCAs up here, we accomplished the same thing by using two channels of the mixer here. We have two channels open. What about putting in another set of these modules here so that we have a second oscillator? I think I'm on sawtooth now. So let's chorus two sawtooths together like we did in the previous episode, but using this new technique. So I selected them by shift clicking. I'm hitting Control C to copy. I just left click here, Control V to paste. And while they're still highlighted and selected, I'll slide them into place. Okay. Now I'm going to move these over because I think visually it'll look a little bit better. So I'm shift clicking each of these. Our mixer and our audio module. Let's move it over here. Alrighty. So what we can do now, if we want to use this, you know what, actually let me move this up a level here so I can zoom in a little bit more. Okay. Now, first of all, we got to hook these up, and we go from destination to source, since volts per octave is already, I ended up clicking on the wrong one, is already hooked up. If you want to hook it up to two destinations, you got to drag from the destination to the source. So volts per octave is coming in there. And then our gate up here needs to go to both process and our ADSR. Our velocity needs to go to process right here. And then we're going to take our second sawtooth now. The first one's going into channel 1 of the mixer where process is controlling it. So we're going to put this one into channel 3 of the mixer. And we're going to have this process controlling it. Now I'm thinking, could we use the same process? We still need to use a separate channel because we need a separate channel for the second audio of this oscillator. We do need that, but we could have the same process governing it because these are receiving the same, these two oscillators are receiving the same velocity, or we want the same velocity controlling them because they're basically two parts of the same note. So let me try that. This is something I'm doing on the fly here. That gets hooked up to glide. So I'll just delete this if this works out. In theory, it should. Now, the output from this one will go to the audio input of this one, basically. Now that velocity is controlling our signal, we then want to control it with a separate gate, or what about the same one? Because this one would be under the same envelope. then channel 4's output comes from here. We don't want to use the main output on the mixer because that would give us a mix of signal with velocity control and a mix of signal with envelope control after going through the velocity. And you'd hear both simultaneously mixed together. We don't want that. We just want to hear the output from, well, hold on just a second. We're basically putting two outputs into the same input here. Does it let us? No. We need another mixer. But I did a little digging around before the episode to see what we have. I wanted to see if we had a 2-channel mixer. There might be some modules for VCV Rack that have that. But I did find, let me see if this is it or this one, a module just called Mix. Now, it has 6 channels. We don't need all that. We just need 2. But it doesn't have individual control mixing of each channel for individual levels. They all get mixed together and there's just one knob for overall level. But that's fine for what we're doing here, as long as we want our 2 oscillator chains here to have the same level, basically. Now, if you want them to have different levels, you would really want to use another mixer like this. And then you have the control over their levels here. So you can balance the 2 together. And in a lot of circumstances, you'll want that balance control when you're mixing oscillators together, because you can actually mix them. But in this case, I believe we're getting both. A good way to test that is the detune one. So there we're getting 2 fuzzy oscillators, and I think we can say, don't need you, don't need you. Because we are talking about doing things with lower processing and a little bit sleeker design. Less cables, you know? And so that works out better. And this is good at this point, and I'm glad this comment came at this time, because now we can employ this thinking in our designs from here going forward. And it'll be more important as we go forward to employ a little more efficiency in our designs, less cable clutter, less processing usage by the computer. I think those VCA modules, since they do have a display with the LED lights going up and down, they look nice, but that probably has an effect on the processing. There's not much of a display here. I know the channels do light up when signals flowing through them, but it's probably less usage on that. And as you get these constructions with tons of modules and connections and stuff, it's good to keep things sleeker. So this is working out well right now. One other thing I want to add, this is going to be a bit of a shorter episode, but I think it's valuable in that it's timing wise, it's a good time to really start employing this type of thinking going forward. But there is something else I found. It's basically something I didn't point out, but I kind of thought it at the time, but I wanted to check a chart first. You notice how in right-clicking on the frequency knobs of the VCOs, it says 261.63. Well, there's a reason why. That's actually middle C. C4 MIDI note number 60 is 261.63 hertz. So there's a reasoning behind it. As we worked with last time, I mean, basically, as the frequencies get fed in volts per octave to the oscillator, it changes frequency as far as what pitch it's playing. And if you adjust this, you can skew that basically. So if we right click on this and go to 263.63, right click on this, it's down an octave roughly right now, but I'm going to make it 259.63. You can always click initial here and it'll go to its initial value, which is 261.63. That's also true for other knobs if you want to go back to their initial value. Like FM, its initial value is 0 in the 12 o'clock position. If you ever are adjusting it and stuff like that and you want to go back to your initial value, you can do the same thing there. But now these are slightly detuned. If I play something, let me see. Is this middle C here? I believe it should be. I can hear a modulation there because of the chorusing, because this is tuned up from a center pitch of 261.63, and this is tuned down. It's 2 hertz up, well, 2 hertz up, 2 hertz down here. I kind of like that timbrely. Now, if I play that C, they're really 4 hertz apart. And I would imagine I'd hear 4 pulses per second, you know, from the beating between the frequencies. I'm hearing 2. 1, 2, 1, 2, 1, 2. Or maybe my time perception's off. 1, 2, 3, 4. Yeah, actually, when I concentrate, yeah, it is 4. 1, 2, 3, 4, 1, 2, 3, 4. You can kind of hear that. Wah, 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 wah. As we go up in frequency, though, just play a higher note there, you hear faster beating. Like, let's just go an octave above. Now let's go 2 octaves above. There, much faster beating between the sounds. So the modulation effect you get from chorusing changes depending on what pitch you play. So the separation we're getting here seems to, it may be proportionally the same as you go up octaves and down octaves, or up pitches and down pitches, but you will hear a different rate of beating when you do that. Now, when you're far enough apart, it's no longer a beating effect in chorusing. Let's say, I'll just use my ear. Let's initialize this one. And initialize this one. Oops. And then I'm going to detune, well, let's tune this one up instead of doing the octave. They're far apart enough in frequency that you're no longer hearing the beating effect. But, of course, the listener is going to perceive an interval there. And so, now, with our new design here, in using the mixer, let's say we wanted to maybe attenuate the second oscillator a bit in comparison to the first. Our new mixer that we employed here doesn't have that. And so It depends on what you find to be more of an ease of use. If you want to use another 4-channel mixer and just use 2 channels of it, probably that might be a good way to go. But you can also adjust the levels here. Since we're kind of daisy chaining here, where oscillator 1 is coming out of the audio output here, going into the audio input here, then coming out from here, you could mix the two by just using channels 2 and 4. So our oscillator 1, the higher one, if we want to reduce it, attenuate it some, we can just grab channel 2 here, pull that down. So that way, when you're chorusing, you can still basically, mix your levels, because there's channel 2 and channel 4 that have the ultimate signal level for both oscillators. So anyway, I thought that this would be useful. Very constructive comment. Thank you, F Ranky. Once again. And yes, I encourage comments. Anything that helps people viewing this series learn, anything constructive. Of course, just shout outs and hellos and thank yous and all the positive comments are also quite welcome too, because they actually, the more comments, the more these videos get seen by people. It helps with the algorithm. And of course, that's always beneficial as well. But yeah, if you see something that I'm doing and have a better way of doing it, or at least think you do, in this case, I think we did find a better way of doing things. Please let us know, because ultimately it's all about learning here. And the more we are like a community and learn together and share information, the more enjoyment and the more effectiveness we get as a result in the sounds that we create and ultimately the music that we make. So thank you very much, folks. Next time we are going to go on to filtering. We'll keep it basic at first, and as we go, we'll get deeper and deeper into synthesis. Until next time, take care and stay free.